I am Mr. Sandeep Dattatreya Kardile, M.Pharm, Pharmaceutics, lecturer, Mola Rural Institute of Pharmacy, Sone, and I am giving presentation on mixing and homogenization, part first. First of all, contents: introduction to mixing and homogenization, the types of mixing, advantages of mixing, propeller mixer, turbine mixer, paddle mixer, and planetary mixer. Introduction: mixing may be defined as a unit operation in which two or more components in an unmixed or partially mixed state are treated so that each unit, particle, molecule, etc. of the components lies as nearly as possible in contact with a unit of each of the other components. Importance of mixing. First, to make simple physical mixture. In the production of tablets, capsules, sachets, and dry powders, two or more powders or granules are mixed. Physical change. Mixing may aim at producing a change that is physical, for example, the solution of a soluble substance. In case of dissolving a solid in a solvent, mixing will take place by diffusion, but the process will be slow. In this case, agitation makes the process rapid. The third, dispersion. In case of emulsions and creams, two immiscible liquids are mixed where one liquid is dispersed into other. In suspension and paste, solid particles are dispersed in a liquid by mixing. Fourth, promotion of reaction. Mixing encourages and controls a chemical reaction, so ensuring uniform products. Objectives of mixing: to ensure uniformity, to initiate or to enhance the physical reactions or chemical reactions, for example, diffusion, solution, dissolution, etc. To make the following products like tablets, suspensions, emulsions, paste, creams. Then factors affecting mixing: particle size, particle shape, surface area, density, porosity, volume, flow property and charge, mixing mechanism, mixing time. Then types of mixers. There are three types of mixtures. First, positive mixtures, formed from materials such as gases or miscible liquids. The materials mix spontaneously and irreversibly by diffusion. No input of energy if time of mixing is unlimited, although time will be shortened if energy is supplied. Generally, these materials do not show any problems during mixing. The negative mixtures. Materials have the tendency to separate out from each other. Energy needs to be supplied to keep components adequately dispersed. Some separate faster, while for others the separation is slower. For example, in suspension, there is the dispersion of solid in the solution, fast separation. Then emulsions, creams, and viscous suspension have a slow separation. See, are more difficult to be formed and require high degree of mixing efficiency. Neutral mixtures. They are static in behavior. Neither mixing nor demixing occurs unless acted upon by an external system of forces. Example are mixed powders, pastes, and ointments. Liquid mixing. Liquid mixing is divided into following subgroup. First, mixing of liquid and liquid. Mixing of two or more miscible liquids. Mixing of two or more immiscible liquids. Second, mixing of liquid and solid. Mixing of liquid and soluble solids. mixing of liquids and insoluble solids. Mechanism of mixing: bulk transport, laminar mixing, turbulent mixing, and molecular diffusion. Liquid mixers: shaker mixers, propeller mixers, turbine mixers, and paddle mixers. This is the diagram of shaker mixer. This is the diagrams of propeller mixers, which marine propeller mixer and clamp mounted portable mixer. Turbine mixers: the most versatile of all mixers in the entire span of mixing equipment are the axial and radial flow turbines. Turbine mixers can be made to handle huge batches, even up to 50,000 gallon, and suitable for emulsification process. Radial flow turbine and axial flow turbine. This is the paddle mixer. Solid mixing: mechanism of solid mixing: convective mixing, mixing of the bulk particles as a whole from one container to another, also known as bulk transport. Shear mixing, mixing of particles using diffusive mixing, mixing of materials by random movement of particles. Shear forces by agitator or stream of air different layers through diffusion process. Then process of mixing: expansion of solid bed occurs, so the mixing equipment should be filled about 60% of its volume. Application of three-dimensional shear forces. Mixing time should be optimum to prevent aggregation and separation of particles. Avoid demixing due to particle breakdown. Then mixing of semi-solid: if the solid is not too coarse, the liquid is not too viscous, and the percentage of the solid is not too great, solids can be suspended in liquids by the use of a propeller or a flat-bladed turbine in a cylindrical container. Apparatus used: planetary mixers and sigma blade mixers used as agitator mixers, and triple roller mills used as shear mixers in size reduction. Then planetary mixers. Planetary mixers are one of the most widely used mixers in the pharmaceutical industry. In the pharmaceutical industry, planetary mixer is often used for basic operations of mixing, blending, and low shear granulation. The machine is also used in other industries like cosmetics and personal care products, food, glass, cements, ceramics, metal industry, etc. This is the diagram of planetary mixer. The planetary mixer have two blades which rotate on their own axis while they orbit the mix vessel on a common axis. The blades continuously advance along the periphery of the vessel, removing material from the vessel wall and transporting into the interior. These mixers are ideal for mixing and kneading viscous pastes or purity like materials. Uses of planetary mixer: planetary mixers are ideal for mixing of pharmaceutical creams, ointment, ceramics, color and pigments, resins, ink, cosmetic creams, herbal creams, etc. Planetary mixers are also ideal for mixing and kneading viscous pastes under atmospheric or vacuum conditions, used in the mixing of viscous, heat sensitive, and cohesive pastes, dough and moist, etc. Lastly, thank you.